I mean, if I were you guys, I'll be very surprised lah. I thought it's just a demonstration and then that's it, lo. Right. Hmm. Are you guys happy with the design first?
Yeah.
All right. But you guys haven't tested the stacking, right? That's about it, right?
Yeah.
For your information, every time you stack 0.25, right, for the first stack, every time you stack, the increase will not be plus 0.25. There will be a
Yeah.
gradual decrease, lah, right? So it cannot go infinite. That's why I say you gotta test until the voltage that you guys want, lah. Um, I'll give you a I'll give you an idea. 5 volt is considered useful, even though it is not in the requirement. Again, do you know why 5 volt is considered useful?
To like a bulb.
Sorry, the what?
Like light up a bulb or something.
Now, lighting up a bulb can be done with 1 point something volt, even sometimes 0 point, very dim. My point is, you guys don't usually light a bulb with a portable battery, lah. That's not what you do, right? Um, Practically speaking, from a design perspective, what do you use a portable battery for?
Like a fan?
I'm sorry, you're saying?
Like a fan? I don't know.
No, your rechargeable battery, your backup battery, you have one, right? To charge your phone on the way? No, you don't have that?
Um, yeah.
Okay, so what do you use your rechargeable battery for? Not to light a bulb and not to blow a fan, definitely not. What is it for usually?
Charge your phone.
I charge a phone, exactly. And to charge a phone, 5 volt. In fact, most of the electronics that you use are 5 volts. It's kind of a standard thing. Below 5 volt, not very useful, therefore. And that's why in the video, you realize that he tries to reach 5 volt. It wasn't a random value. It wasn't. It wasn't at all. Did you see that in the video?
Yeah.
He probably explained it, he probably not. And your syllabus certainly do not explain it. But 5 volt is the standard for all electronics, at least the small one. Not a laptop, but most small electronics. That is what is considered to be useful these days. Totally not in the syllabus, and I think that's precisely why the project might appreciate lah if you guys try to reach, not a random value, but a 5 volt value. Do you guys have to do that? Of course not. Of course not. But from the design perspective, I think requirement 2, right? Requirement 2, that might make some sense. So it is up to you how many volts or how many watt you want to stack, but that's one reasonable goal for you guys. Maybe 20 or 25 stacks. Now that I've said that, what I'm going to say is regarding the liquid lah. Because if it is 2 stack, it's actually very easy to maintain the wetness of the towel lah, the graphite towel. It's very easy. 25 stack, a little bit harder, a little bit harder. Now, shall we talk about 2 stacks, 25 stacks, 10 stacks? What do you want to talk about if you want to talk about?
Like 10.
Okay, let's talk about 10 first. And if you can make 10, maybe you can make 2 times 10. Who knows, right? I don't know. That might work, right? What is your team's solution to, to maintain the wetness of the liquid? Any idea so far?
We haven't really thought about it, but I think
Yeah.
we didn't really touch on that yet.
Right. Let me show you some. Can I? Can I? Yeah. The good news is they only test for a while, right? They don't test for 1 hour, 2 hours, right? In the after 4 weeks, they will test and it needs to run only for, I don't know, 2 minutes or 1 minute, something like that. Is that reasonable?
Yeah, as long as it reaches like 1.2.
Yeah, I think it would be quite easy to do so. Let me just draw something for you. Now, is that the most important problem right now? Just to confirm before we discuss about it.
Yeah.
To you is okay. All right. Okay. Let's talk about it. And to confirm, you're updating me this because this is what you want to talk about, not the school topic, not yet. Number one is project, correct?
Yeah.
All right. All right. So in the Jamboard, I'll give you some idea. Or in fact, like this. In fact, I want you to sketch your aluminum air battery. Can you sketch it? Because you need to sketch it for your report anyway. Can you sketch how it looks like, I guess, or how to make the design of the bag? Sketch it, and then I'll give some idea on how to wrap it up so that the liquid is not gone. Okay. Okay. With the stacks, yeah, you want to draw one first, and then you want to draw a few, right? Okay, I believe that's the copper, I think, right? Okay.
Is
All
one
right.
layer enough?
One first, because one is at least one cell, right? So what's the strip connected to the aluminum? Make it clear.
Sorry. Oh,
What's the strip connected to the aluminum? I assume that it was connected. The strip connected to the aluminum is copper. I guess that works fine. Okay, okay, okay. Okay. Now, I understand all this because I see the video. However, because I see the video, I know that this is not all. For example, what's the salt water doing? Is the salt water important for the battery? If it is, you gotta put it in the diagram, something like that.
wait, I'm not sure if we need a diagram.
I'm not too sure. What? Sorry?
I'm not sure if we need a diagram. I think of pictures.
You mean taking pictures with your phone, something like that?
Mm-hmm.
Don't be so sure. Having said that, a hand-drawn diagram is okay if there isn't. If I'm wrong, I'm very happy. I'm very happy if you don't need to draw a diagram. I'm very happy. It's not the easiest thing to do, lah. But in case you end up needing it in your report, this drawing is better than nothing. Already better than nothing. Totally needs improvement, but already better than nothing. Totally better than nothing. Okay. Okay. Now let's try. Let's try. Let's see. Yeah. Mine in red color. Yeah.
Mm-hmm.
So, well, another thing is probably you want to do a connection, something like that.
Oh,
I'll
okay.
just put this as a voltmeter in general, right? That's just how you declare that it's a working battery, right?
Yeah.
So normal. And then a positive, negative. You have any idea which ones are positive and negative?
Wait, I can't hear you.
Okay. Do you have any idea which one's the positive and the negative? Very important for the battery. Okay. So assuming you're right, you're saying that the electron will flow like that, correct? And
Yeah.
you're saying it's just around 0.25 volt for one cell, something like that. Totally, it's actually quite good. Like, but
Wait,
believe
it
it or not.
wasn't 0.25, it was like 0.05.
Oh, dang. We have a
Yeah.
problem. Oh, we have a problem. Oh, we have a problem right now.
But we did use graphite paint. We like used pencil, but it didn't really work that well. So we're trying it with the paint.
Oh, man. No, 0.05 will not work. No,
Yeah,
it wouldn't
yeah.
work. No. No. Okay. Let's talk about it. Okay. Again, 0.05 doesn't work. You gotta, yeah, that's just too far. Okay, let's talk about it. Now, if I'm not mistaken, what's the single snack volt of the video?
Like 1.25.
Huh? Single snack 1.25. Single snack, really? Oh my goodness.
It was like at least 0.8 something.
Okay, let's talk about 0.8 maybe. Yeah. Okay, 0.8 is already very good, right? Okay, so before we even talk about the drying part, you got to solve this problem first. Okay, I think we can agree on that. Before that, I'm going to check all the positive and negative first. If you're saying that is negative electron going in, now who is going to, okay, what's the reaction here? Again, helping your O level here, what's the reaction?
That's all.
Theoretically, what is it?
Wait, what?
What's the reaction here?
What?
Oh, I noticed that your positive and negatives are already wrong. Your positive and negatives are already wrong. Oh dear. Again, what's the reaction here? If you cannot write down the reaction in your report, it's really not going to be good.
Reaction where?
I'm supposed to ask you that. Not you.
Oh,
We talked about it. We talked about it so much last time. Oh dear. Oh dear.
like the reaction that happens in this.
In this battery, yes. In the end, this is a chemical battery, right? I mean, there's no other battery. A battery is always chemical. You gotta talk about the reaction, man. And you will realize that your positive and negative is wrong because of that. Okay, so check out the reaction first. Check out the reaction. Good. Oh, wait a minute. I'm the one which is wrong. What am I talking about? No. No, wait. I'm the one which is correct. I'm correct. I'm correct. I think you're wrong. Oops. I think you're wrong. The reaction is fine. You're good. Sounds great. And it will happen at the aluminium, right? At aluminium, which is great. Now, let me show you why it is wrong in terms of the electron flow. So look at the aluminium. The aluminium will release aluminium 3 plus and electron, which is here, right? Here. Okay. Now tell me, where will the aluminium 3 plus go and where will the electron go? We talk about it. It probably will feel new lah. Where will it go?
Into the salt solution.
Who into the salt solution? Which one?
The electrons.
Okay. This is the new thing I told you, and you're going to put it in your notes. Not for the project, but for your O level. Electrons cannot go into solution. There is almost no way for electron to dissolve into the solution. Almost no way. On the flip side, electron really like to go to somebody else. The electron has two options, to the salt solution or to another place. Do you know what that is?
The hydrogen.
No, the wire.
Oh.
And the reaction happens on the aluminum, right? This big thing. And then releases electron and aluminum 3+. Electron does not like to go to the solution. It cannot dissolve. You have never heard of electron dissolving. Doesn't work like for the electron. But it will really like to go to the wire, because that's what electron do. Electron does flow in wire. You're a physics student, you know that, I suppose. Make sense? The wire. To wire. Now, this is important for your O-level and therefore for your project. The electron will be exiting the aluminum. Make sense?
Yeah.
This electron will be like that instead. And therefore, this is not positive, but negative. Does that make sense? That is what a battery do. It ejects electron from the negative end, if that makes some sense.
Yeah.
Which means like that, and which means this is a positive. Okay, so descent to wire and aluminum 3+, where does it go for your O-level? Can you hear me?
Yeah. Yeah.
Aluminum 3+, 2. Stays in aluminum, goes to the wire. Where? Where does it go?
Like around the aluminum.
No, it'll go to the solution, which you kind of expect from chemistry. Oh, aluminum 3+, oh, ions, oh, great. Ions dissolve in water. Water is ionic. Ions are ionic, I guess. Secrete. Make sense?
Yeah.
So that will dissolve, and that's important for your O-level, right? So therefore, mention it in your project. It will look good, it will look good. You understand the theory, okay? Let me check all of that. The receiving of electron. Okay, this it looks good, right? Okay. Ejecting electron, receiving electron. That looks pretty much correct, right? At the other end, you got a reaction which receives the electron. You know, pretty much great, good looking. The one that received the electron is a H+. Who are the competitors? I mean, Al3+ is there, right? It's a competitor, and this will lose, right? This will lose. H+ and nobody else. Okay, good. Good. Yeah, good. Now, in your diagram, these are really in your report. These are really the minimum you have to draw. Not minimum you have to write. This is truly minimum. These two things. Like, there's no way you don't write this. Now, if you're gonna write this, you need either a very good picture or a diagram that you draw. Either one is fine. I hope that makes sense.
Yeah.
Okay, either one is fine. Yeah. Now back to the problem. Your graphite paper, I don't suppose you take a picture of it?
Like we didn't take a picture.
Okay, could you please confirm what you did? Like really in detail what you guys did.
We like took the copper strip and put it like on the paper towel, and then in the video they painted it with graphite paint, but we just tried it like using like pencil, and we scribbled on top of it, and then the rest was the same as the video.
Oh dear. All right. So a pencil does not draw very well on paper towel. Am I correct? That's part of the problem. If you use paper, it would have been better. If you use paper, it would have been better. I gotta show you why. Right. So,
but wouldn't it be better to use like tissue paper so that it will absorb the salt solution better?
All right, let me show you the why. And this is back to theory. This is back to O-level. So always good. We're not discussing just for the project, right? Okay, so let me show you. Now I'm going to draw it from a very traditional drawing. This is a more traditional battery drawing, right? If that makes sense. And this will be your copper. This will be your aluminum. This will be your voltage, right? Okay, and this will be your salt solution, which has your Na plus. Oh, I forgot. There's a competitor Na plus here, which also will lose, right? Everybody will lose the H plus, right? Na plus, H plus, Cl minus, OH minus, right? Okay, good. Now, would it surprise you that this is actually not the traditional drawing of your battery? The traditional drawing of battery is actually like this. Look at, instead of Cu, this should be C. Your Cu is here, the wire. Even though it looks like the Cu is the one of the cathode anode here, but actually it is the graphite making contact with the salt solution, actually. How come I can say that? I'm very certain about this because the way the design of the battery is, they maximize the contact between aluminium and salt water by simply stacking them together. Make sense? Aluminium and salt water, a lot of contact. The aluminium is very big. Am I making sense so far?
Mm-hmm.
It doesn't make sense for them if they want copper here to be in contact with the salt water to make the copper a small, tiny, itsy bitsy strip. Just make the copper as big as aluminium. Instead, what they do is that they make a graphite paper. Why? Because area of contact aluminium the same as area of contact of graphite. That is what they are trying to achieve. Contact with aluminium and salt water, contact with graphite and salt water. The copper only matters as a wire, as a conductor, not for the chemistry. Anyway, you don't see the copper reacting anyway in that sense. Am I making any sense? Now, having said that, you can replace Cu entirely with a big strip. You can make the Cu big strip and do without graphite paper. You can actually do that. Big strip aluminium, big strip copper, dip it in water. So let me draw that. So big strip Cu, big strip aluminium, dip it entirely in salt water. That will make your battery much better in terms of voltage, definitely. So here's the big Cu and here's a small wire Cu, the voltage. Again, this will immediately improve your battery voltage simply because of the contact, the surface contact between saltwater Cu and saltwater aluminum. Am I making any sense? This is without the graphite paper, sorry. Do you know what's the disadvantage of doing this then?
The liquid won't be absorbed properly.
Yep, you have to deal with the beaker, basically, and it won't be very portable. So you'll probably score well in the first requirement, but second requirement, third requirement gone already. Makes sense, right?
Yeah.
Now, please acknowledge that you can replace Cu with anything else. So to speak, you can actually replace Cu with carbon. It doesn't matter because the carbon is not reacting, if that makes some sense. You can replace this with silver if you want to. You can replace this with graphite. You can replace this with lead. You can replace this with iron. If you want, you can because they don't react. Am I making any sense theoretically?
So you can replace the copper with
anything below aluminum. Anything below. I mean, the lower the better. The lower the better, I must admit. The lower the better. But still, anything below aluminum will work fine. which you have a lot of options. Theoretically, it will work. The reaction will still be like that one. If that makes some sense.
Yeah.
Okay. So why, from a design point of view, not from a theoretical point of view, why the design choose graphite? Why? Because graphite paper. Paper absorbs. Absorbs what? Absorbs the liquid. And graphite is a powder or paste that you can also put on the paper. You cannot do that with any other metal. Only a graphite powder plus paper will be able to absorb salt water reasonably. That's the point. That's the point of the design. You're trying to eliminate the cumbersome liquid by absorbing it, so to speak. That's his reason of choosing graphite. He probably didn't explain that. Does that make any sense?
Yeah.
So paper accomplished three things, yeah? I can make it conducting by using the graphite powder, which explains why your paper towel doesn't work very well, because your paper towel is not very conducting. Not very conducting. It's not very conducting. It probably absorbs the salt water, great, but again, it's not conducting much. The surface area is very bad. So it doesn't give you a very good battery.
Yeah.
Again, make the graphite surface area very big and make the paper towel kind of thick, if that makes some sense. That's what you must do. If you're sticking with this design. I'm telling you all this because the video might not explain. One, two, because you have to justify your design. The moment your teacher see your report, this is a CU, but the graphite paper is there, he knows that you guys don't understand. Really don't understand. Don't understand the point of the graphite paper, don't understand the point of salt water, and therefore immediately, obviously he knows that you can see this in YouTube. He will have that, he will know that from, it's not that he minds that you guys copy from YouTube, but he will mind that you guys don't understand the design. You just follow the design. So he find it a bit hard to give you the design mark, even though the design is not bad. I hope that makes some sense.
Yeah.
That's why I'm talking to you about the theory. If you don't get this, it will be very apparent when you do the presentation or do the report. Okay. Something like that. So Ria, maybe you ask questions first, make sure that you understand so you can at least explain to your team and maybe you guys can brainstorm that. Please make sure that you understand the theory first.
Yeah.
If you do, maybe I'll give you some idea, I guess. Now, I take it that you guys don't know where to buy graphite paste, correct? What's a graphite paste or graphite paint? You have no idea, correct? Very confusing.
Is it possible to just like use pencil that and mix it with paint?
Mix it with what, sorry?
Mix it with paint.
Mix it with paint. Okay, here's the problem. The paint will allow you to coat, right? Which is nice, right? Maybe you ground the pencil, right, into graphite powder, mix it with some sort of paint, and then you paint it on top of the towel. Here's a problem. Most paint are plastic and plastic are non-conducting. Did that make some sense? The paint or the paint itself will hinder your conductivity, very bad for a battery. Again, I hope that makes some sense.
Yeah.
What other ideas might you have before I give you mine also? Can you hear me? Sorry, can you hear me?
Yeah. I don't know.
All right. I'll just give you some idea. Whether you like it or not, it's up to you because you guys are the one that gonna test it. At this point, please remember, the more idea you test, in some sense, it looks good on report. Oh, I tested graphite paste mixed with paint and the result is bad according to my teacher. Well, I mean, who cares, right? That's my theory. You guys should test it out. It does look kind of good in the report if you have 2 or 3 failures. Do you understand?
Mm.
Kind of shows that you guys are trying stuff, even though it may or may not work. That's the whole point. That's the whole point of the design part of the report. So please include 2 or 3 failures and maybe 1 or 2 good design. You'll be very good if you have 2 compatible design. Then that will make for a very interesting report. Now, here's my take on the design. Okay. I think you can use a thick paper, you know, the kind that you can buy in Popular, you know, some sort of semi cardboard, maybe 200 or 300 GSM kind of thing. Do you understand what I'm saying?
Yeah.
Okay. Because this is a paper, it will first of all absorb well. Okay, you'll absorb well. Absorb well, that's number 1. Secondly, you can simply draw on it. Draw graphite on it, right? Draw pencil on it. Use a very, you got to experiment lah. Maybe 6B pencil, maybe 2B pencil. Who knows which one's better? I don't know. I can guarantee you that they are not pure graphite. Do you understand what I'm saying?
Mm-hmm.
6B pencil, 2B pencil, don't know what's the content of a graphite. You should at least test 2 pencils and find out which one's better because it's not 100% graphite. So I think the filler material will not be conducting. It might be a problem. All right. Graphite paste is better. It's just that you don't know how to buy. So let's use what we can buy. And so it's fine. But please test more than 1 type. Now, if you draw the pencil, it will be good enough surface area lah. So hopefully surface area also good.
But with
Surface
the
area.
thick paper, how do you like make sure the thing gets absorbed?
Make sure what? Sorry.
Make sure like the thing gets absorbed properly.
Okay, so you take the paper and both sides you're gonna coat with the pencil, right? You just basically color pencil it lah, correct or not? Color pencil until it's dark gray, correct?
Mm-hmm.
Should be no problem. You just soak it on the salt water, then that's it. I mean, it's a paper. You will know when it soaks. You will know what, definitely. Definitely you will know. I hope that makes sense. So I suppose the thicker, I mean, you have to experiment with thickness, but I think going on the thicker side is good. You can even try cardboard, you know. Nobody stops you from trying cardboard. Do you know what I'm saying? Like the one they use for packaging, cardboard. Nobody stops you from trying that. I mean, I know which one will work, you see, and I won't tell you, but I can tell you that those things are worth trying because at least they absorb and you can draw the pencil quite easily. Okay. I am pretty sure any of this will already improve your voltage one. Probably not go to 0.8, but probably go well beyond 0.05. It will be way better. It'll be way better. Right. That's my take if you want to not use graphite paste. Okay. The advantage is you're using materials that can be easily obtained. So that should be good.
For copper, is that like, wait, do you think you can get copper like a hardware store? Like, is it easy to get?
Okay. Yes, copper strips. Now first thing first, again, I believe he used copper strip just because it's easy to paste. You know, easy to stick to the graphite paper, easy to stick to the aluminum. It's basically wire. Better use copper strip than wire because wire very difficult to stick to aluminum and to the graphite paper. You understand? Copper is not It's not the thing here. It's really just for conveniences. And yes, copper strip can be bought quite easily in hardware store. If you're going to visit a hardware store though, you might as well ask for a graphite paste lah. Might as well. Maybe they have, maybe they don't. If they have, please try the graphite paste and also please try cardboard or thick paper. You should have at least 2 or 3 designs for comparison, remember? It looks good on the report. I compare this, I compare that. This is like this is like that. This is an advantage, this is a disadvantage. Those kind of things, the report, is what your teacher is looking for.
Okay.
Ask more questions regarding this thing first before we talk about how to prevent drying lah, so to say.
Okay, I think this is okay.
Okay, hopefully that's not too bad for your team. Again, I apologize for not sending you the voltmeter. I'm just full this few weeks with the BE. Can I confirm that your team still would like the voltmeter?
I think if you can, then yeah, sure.
Yeah,
but
not too late. Okay, not too late. Okay, I'll try my best. Okay, I'll try to send maybe today. Okay, so that I don't just forget about it for another week. Okay, very bad of me. Right. Okay, now regarding the drying part, there are 2 basic solutions. Okay, 2 basic solutions, and it's good to combine them if you can. Let's go to the next page. Now, on the video, you will notice that he doesn't give you any packaging at all. A real battery must have packaging. If that makes sense?
Yeah.
Now, since he already used the sheet towel that absorb water, the packaging does not need to be glass. So I'll just draw a few sheets here. Let's say you put in, I don't know, 40 sheets. Let's say, let's say you put in 40 sheets in the end. So 2 times 20 sheets, basically, right? And then the thickness is around, I don't know, the thickness is around at most, what, 5 centimeter? Like, okay, let's say pretend this is 5 centimeter. It's 5, yeah, 5 is a bit too much already. So 5 centimeter maximum. Doesn't look so big, right? So shouldn't be a problem. Portable, not too heavy and everything. All you have to do is wrap this in something. First of all, watertight, okay, waterproof, makes sense? Because the inside is still liquid, you have to be waterproof. It has to be non-conducting. Does that make any sense? You cannot wrap it with aluminum. Not good.
Yeah.
This is part of the design, and maybe to part 3 also. I don't know, to part 3 also, maybe. So waterproof, non-conducting. And then out of that, you have to have 2 terminals jutting out for the connector, the plus and the minus. That's it lah. Those has to be exposed, but that's about it lah. Those have to be exposed. So this part will require some sort of seal because you gotta expose it. So you gotta make a hole. So there has to be some sort of sealing here. If that makes some sense.
Yeah.
If you don't seal it well, the battery will leak lah. When the battery will leak, after a while, the battery will not work. Nobody's gonna die by the leakage, but the battery will die. But nobody will be harmed. That's okay. That's fine. So think about this wrapping for a while. What can you use so that it's gonna be waterproof and non-conducting?
Like the plastic tape.
Normal tape, you mean?
Yeah.
Yeah, works fine to me, Works fine to me. I mean, I have my own preferences, but any form of tape, any form of cling wrap, if that makes sense, cling wraps, a combination, whatever, all those things should work very well. Okay. Anything else that you may think of, which is waterproof, non-conducting, tightly sealed, sorry, I forgot, tightly sealed, is gonna be great. And these are the materials that you have at home. So fair enough. This is the first solution, and this is a solution that must be done anyway. Even if your battery dries out, you still have to do this. This one have to. Correct? Make sense? This one have to. So far, so good?
Yeah.
Any question before you try? This is the first one.
No.
Okay, second one is bonus feature to handle the drying thingy. Okay, this is a bonus feature. It shows that you are thinking ahead. It shows that you're thinking ahead and you're thinking maybe in 4 weeks, your battery will dry. You put in this bonus feature and then hopefully it'll look good in your report. It'll look good. Okay, very simple. Since you already have to have a seal anyway, right? Remember, you have to have a seal here for the positive and negative terminal. Correct or not? Like, for example, this is a wire, but the wire will jut out from the plastic or whatever wrap, and they have to be a seal. Then you can make the seal. This one is wrap, right? Call this a wrap. Wrap or package. So make the seal open and close. It can be open and it can be closed. If this can be done, you can top up the salt water. Simple, right? You can top up the salt. Now, let me show you why this is a good idea, right? Or rather, it is a reasonable idea. I'll show you. I'm gonna take something. Okay, I'm showing you a drawing, a photo of a battery that exists in cars. I'm not talking about electric cars. I'm talking about normal cars. Okay, this is a lead acid battery. They call it dry. Don't be fooled. Do you see this? Do you see this yellow thingy? This thing, yellow thingy. This thing.
Yeah.
You can open that. Inside are basically liquid acids. Liquid acids. This lead acid battery, simply put, requires topping up. It requires topping up of acid because he consumes the acid. And that's why they built in a, open and close cap, so that, you drive into to your car maintenance and then they will just top up the battery and the battery will work again. My point is, this is a working battery used in a car, not portable, but extremely cheap and extremely powerful. It's just that it is not according to your design. So it makes sense if you just, try to incorporate this feature in your own. Should be no problem at all. If you can do it, that would be great. Am I making any sense?
Yeah.
Right? Yeah, something like that. Okay. If you want to do this, if you have time, must remember that the wrapping, or rather the wrap, can be rigid or non-rigid. It can be a rigid thing, or it can be non-rigid. All the tape stuff are non-rigid. A plastic box, this one is a battery, right? This is a plastic box, isn't it? A plastic box is rigid, is waterproof, is non-conducting, and is tightly sealed also. You can make or use a very small plastic box that will fit all your stack. That will work also. That will make it portable. Am I making any sense?
Yeah.
Right? So I've given you quite a lot of idea to make the battery hopefully a good design. They're good. How I'm going to find the container, how I'm going to make it non-conducting, yada, yada, yada. That will be up to you. Any questions?
No.
If you're happy with this project, we can move on to the question. If you're not, you can still ask questions.
Yeah, I think it's done.
Who's going to write the report? Yeah.
All of us. Yeah.
let's just say that as your tuition teacher, I will expect a lot from your report, not just your teacher. Okay. Because a good report will cause you to understand the chemistry, which is that's what I'm chasing. I'm chasing after that. Okay. I would expect a lot. Okay. What's happening in class right now? Besides the project.
Oh, just electrolysis, yeah.
So let me confirm that the class is ongoing. It's not just full project.
Yeah.
The electrolysis discussed by your teacher, do you understand?
Yeah. I think there's like one part that I kind of don't get.
Which is, show me in the next page, anything. Please ask.
Wait, can I just check what like preferentially discharged means?
Oh. In our term, it is who wins the competition. Do you understand? Who wins the competition? This guy is preferentially discharged over somebody else, which means that guy wins. Wins either in losing electron or in gaining electron. There are two competitions going on. Am I making any sense right now?
How do you get the overall reaction?
I cannot hear you.
How do you get the overall reaction?
How do you get the overall reaction? But we've been talking about that since a long time ago. Huh? What? Oh,
Yeah.
you mean how to combine the half reaction?
Yeah.
Wait,
like,
we
I know
also
that we did that, but I like one of them kind of doesn't make sense to me in the example that she
all right. Let me show you. Using the project first, okay? Using the project first. Okay, so in page 6, I gave you the reaction that you wrote, right? You have decided that aluminum wins and you have decided that H plus wins. So good for you. This is half reaction. Now, let me confirm one thing with you first, yeah? Half reactions are more important than the total reaction. For our understanding purposes, half reactions are the thing, not the total reaction. The total reaction doesn't tell you much actually. But total reaction will give you extra marks because that is what they want. I hope that makes some sense.
Yeah.
You gotta get the half reaction correct. There is no way for your total reaction to be correct if your half reaction is not correct. The thinking must be clear. I always teach you a half reaction. Now, total reaction, extremely simple. Remember the electron flow? We go back to electron flow. Okay. Let me ask you something. Let's say this is aluminum giving 3 electron, correct? Here's your 3 electron. But for the hydrogen, he received 2 electron. Okay. Make sense so far? That's what is happening, right? This is the battery. The battery, negative, the battery. So on the negative end, aluminum gives 3 electron. On the positive end, hydrogen plus receives 2 electron. Is this, how do I say it? Does this make sense physically? Give
No.
3, receive 2. Now tell me why.
Not balanced.
What happened to the remaining electron, right? The electron cannot just disappear or appear. So if you already know that that's a problem, you already know the solution. What's the solution then?
Balance the electron.
And what do you mean by that?
Make the electrons lost and gain the same.
Go ahead and do it. It's simple math. It is really simple math. This is like a simultaneous equation in EMAP, something like that. You're trying to eliminate something. Okay, times 3, all right. Okay. If you times 3, then This should be 3, right? Correct? Just to confirm, it should be 3. Oh, please don't do that. Oh, no, no, that's just bad. That's really bad. 3 of aluminum 3 plus, if that makes some sense. This signifies 3 ions.
Oh, wait.
Yeah, which is not times 3. Good, good. Shouldn't be times 3. Looks good to me. The other guy also looks good. I like it a lot. Okay. Okay, so far so good. Everything is correct here and here. Now you total it, right? Now you total it, just like math. Okay, now traditionally, you will scratch it here. And then you just have to write one line below. Understand? Just traditionally, that's what teachers do. Okay, then you don't have to write 2 times. Okay, so presentation-wise, this is unnecessary. Save you time in exam. Can so far so good? Are you okay?
Yeah.
Your totaling of reaction is great. There is no other thing. This is the simple principle of totaling reaction. To me, it's very obvious that you understand. Show me what you're confused about, because your basics are great.
Wait, I'll send it to you. Yeah, the part that I drew on, I didn't really understand.
The part that you what sorry?
The part that I drew on, I didn't really
The
understand.
part that you drew on, sorry, what sorry,
I sent
did you
you
send?
the.
Oh, you sent me something. Okay. Sorry. Okay, I'm gonna put it in the Jamboard. Page 7, please. All right. It takes very long. I'm gonna look at your WhatsApp first. Oh, I see what you mean. Ah, he's being fancy. He's being fancy. Your teacher is being fancy. While waiting for the picture to load, do you remember in Sec 3, you learn ionic reaction? Ionic equation, sorry, ionic equation. Did you remember that?
Yeah.
ionic equation kind of cancel certain things from the original equation, if that makes sense. So I'm going to do that here. I'm going to return this. This one is an overall reaction. That's fine. I'm going to return it to ionic reaction, but still also total. Both are total reactions. Both are total reactions. Both are total. This one is half. Half and half. So again, I'm returning it by, remember, when you want to do ionic reaction, you got to split the aqueous stuff, right? That's the rule. You got to split this guy, NaCl. This one, no split. This one is no split. This one just normal, H2O. This one is also split because it is a Na, it's a aqueous. This one, no split, H2, and this one, no split, Cl2. Why am I splitting the aqueous one? Because the aqueous does split in water. They just naturally do that. Am I making any sense?
Yeah.
Okay, so now with that in mind, I will get to ionic reaction, cancel this, right? Oh, this is the complicated part, right? Okay, so H2O do get split naturally by itself, although still a little bit. So they do get split. I am so sorry. I should have just done that. This is also a knowledge from Sec 3. Sometimes people get it, sometimes they don't. So H2O does split in a small amount by itself. Can you accept that?
Yeah.
Because of the split, I can now cancel OH minus and OH minus also. And that's it. I cannot cancel anything else. If that makes sense, my ionic reaction will now be 2Cl minus left behind. There you go. Right. 2H plus. And I think arrow. And I think this one H2 plus Cl2. Both are gases. These are still aqueous. Okay. My ionic reaction makes sense or not?
How did she get the overall reaction from the two half reactions?
Right, right. So here's the kicker. You never have to do overall from ionic. You have to do the reverse. I have to get the ionic from the overall, right? From the complete reaction, so to speak. But you have never had to do the other way around. And in this situation, what you are doing is to do the other way around. So it looks very weird. You're supposed to do that from half, right? First is the half. Second is the ionic reaction total. And then third is the overall. That's the thinking process. Make sense so far? So what he does is just to observe what is left behind in the electrolyte. What he does. I mean, to be fair, Na plus is left in the electrolyte. Correct or not? To be fair. Or let me put it another way. Sorry, let me put it another way. Here, I mean, let me put it the simpler way. You know that the electrolyte starts with NaCl, correct or not?
Yeah.
So you know straightforward that, hey, I should be writing NaCl even though only partially it is used. I know that the Na plus is not being used. I know that. But I start with NaCl, so I'm going to write down NaCl, keeping it simple. Correct or not? That's the easiest thing. So to my ionic reaction total, I will first add 2 Na plus, and as a result, I also must put 2 Na plus on the right-hand side. That is what I'm going to do. First thing first. Understand? Because I noticed that I do start with NaCl. So in your project battery, you also start with NaCl in that sense. After you get the total ionic reaction, you just add 2 Na plus on both sides. Or in your case, 6 Na plus. So far, so good?
Okay.
Okay, first thing first lah. Na plus is the easiest thing lah. Is the easiest thing. That's your total ionic, right?
Then you add any like 6 any plus.
Go ahead. So don't write new stuff. Just say plus first lah. No, stop. Just plus oh, you need to plus NaCl on both sides because they both don't use that, right? So yeah, it doesn't matter how many NaCl is there. It doesn't matter. One NaCl is fine. You'll find that they cancel both. They cancel. You'll find it. So just plus NaCl plus NaCl, acknowledging that it's there, but it doesn't matter. It doesn't matter. Okay, first thing first. Ken, so far so good? Now, let's observe your teacher's example again. You should also notice that in your teacher's example, the H plus comes from water. It doesn't come from acid, correct or not? It just simply comes from water.
Yeah.
So you notice that water will always have OH minus as a counterpart, right? This is from NaCl. And this is from H2O. So you add 2OH minus, right? 2OH, I'm so sorry. 2OH minus, also plus 2OH minus. There you go, from water also. Now, in your case, should you do the same or not? Like, for example, where does the aluminium come from? From aluminium. That's it, Lo? Okay. Where does the H plus come from in your case?
Aqueous salt solution.
Which is to say the water part lah, correct? The water part. So go ahead and add 6OH minus.
On both sides.
I hope that makes sense. All right. Now let's see, is there anything else? How do we know that we stop? It's very simple. In your teacher's example, I've already considered the Cl minus coming from NaCl. I've already considered the H plus coming from water, and I don't see anybody else, so that should be it lah. In your side, have you considered where the aluminum comes from? It's from aluminium. Okay, done lah.
What
Right?
about
Done.
copper?
Again, does copper react or not?
Oh, okay.
That's the question. Is the copper there for wiring purposes, conducting purposes, or for reaction purposes?
Conducting.
I hope that makes sense because in your teacher's example, there's also wire one, but you never bother about the wire. Right? If that makes some sense. Aluminium, done. H plus coming from water, done. NaCl is there. And so it turns out later NaCl you also cancel. So NaCl is there just for conducting purposes. You got to make the water conducting. NaCl is the easiest way to do it. Turns out that's what it is. Please write down your total overall reaction. Hopefully this is not surprising. In your total overall, you should also see NaCl being cancelled. So it doesn't participate in the reaction at all. It shouldn't be there. We're just plus NaCl for exercise purposes. Just like the same as, oh, I have a Cu here. I also have a Cu here. You know, they also cancel each other. If that makes some sense. The NaCl doesn't matter here. It's a bit different in your teacher's example. Now, the way you write it down, you ought to combine this, right? You ought to combine this, and you ought to combine that. Make sense? All right, go ahead.
So do I just cancel out the NaCl?
Yeah, just like you just in your report, you literally just cancel it if you want to include it. Canceling it is an acceptable way of presenting to show that you know that they don't matter, right? Don't do that. What's the combination of Al 3 plus and OH minus? The combination of them, they are both positive and negative ions. So you don't do that. You basically put them together. When put together, what do they become? Okay, good, good. I'm glad to see LOH3. Your chemical formula is getting better, and with the two, great balance. Good, good. I like it. I like it. Okay, in the final reaction, you will need to have the state symbol, but for now, this is very good.
So that's the overall reaction.
Yeah. Would that make some sense?
Are we supposed to know how to get this from ionic equation?
I have never seen exam ask that. Again, in O level, they have a tendency to go from overall to ionic, not the other way around. As far as I can tell, they are interested in the ionic, not the overall. Having said that, what your teacher do is not wrong at all. It's correct, and it's not difficult to figure out as long as the marks are worded, if that makes some sense. It takes some time to figure things out, but not difficult to do. In case they ask in exam, it should be worth the marks. Because they know you gotta take some time to think about it. So they have to give you some additional mark, at least one more. Am I answering your question?
Yeah.
You can figure it out. Let me confirm.
Yeah.
All right. It is a good question, though. It is a good question. If you don't have any question right now, I want to ask you a question. Go to the next page, please. I have been wanting to ask this, right? Okay. Let me confirm, Ria, that have I ever asked you to, grade your class? Okay. Let me confirm that we have never done that before.
No.
All right. Now, this is something important, so I understand what's going on in your class, right? Here, I give you the scale from 10 to 0. 8, 6, 4, 2, 0. 10 being the most perfect class and 0 being the worst, right? Nothing less than 0, nothing more than 10. Ria, you have been attending school, I don't know, for 10 more years, 10 years plus. Could you think about the best class that you ever had, whether primary or secondary? The best subject class. Do you have that in mind? Tell me what subject, please, and tell me what level.
P6 math.
Ooh, P6 math. Like it a lot. That's very helpful, isn't it? P6 math, the best class ever. Could you please give your best class ever a grade of your choosing? That's totally up to you.
Like 10.
10. I've never seen a student give 10. This must be the best thing ever, right? Okay. Now I wish I'm there also. Makes me wish that. Right? Okay, P6 math. Now the worst. The worst one.
Probably Sec 3 Chem.
Oh, you have just answered my question. Okay, so for this worst class, Sec 3 and Sec 4, sorry, does this include Sec 4 math? Is it still the same thing?
Wait, I said Sec 3 Chem.
Oh, Sec 3 Chem is different from Sec 4 Chem. I see what you mean. Okay, good news, good news. So tell me your grade, up to you, of your Sec 3 Chem.
Like 3.
3. I mean, I've seen student give 0 or -1. So, Sec 3 Chem. There you go. Good. Now this is your worst, and this is your best. Great. We have a comparison. Now, what's your Sec 4 Chem?
Like 5.
5. Okay, 5's good. Five's better. Sec 4 Chem. Just curious, for example, your physics class, Sec 4 physics. What's that?
Probably like 6 or 7.
6. 6. 6. Well, okay, 6. I thought it's higher. 6.
6
6.5.
Yeah.
6.5. Physics, Sec 4. 6.5.
Yeah.
7. 7. Yes or no? 7. 7 or 6.5.
Like 6.5. Yeah.
6.5. It is 6.5 for Sec 4 physics. Just like this, I feel that you like physics much more than chem, right? Okay, but the class doesn't help. The class doesn't help. Could you please share with me, if you don't mind, what made Sec 4 chem better than Sec 3 chem? As far as I can tell, the teachers are usually the same.
Oh, my teacher changed, and I think I understand better with the new teacher.
Right. Okay, that's a good thing. Even though it's 5, it's still an improvement than 3. But now I know why your basics are very weak. Now I know, right? Unlike physics, chemistry built on basics one. Physics, each topic a bit different. You know this, but chemistry cannot. So, but the good thing is, once you get the basics, everything should be easy. So to speak, right? Can't say the same with physics and AIM. I know. Did the note change also, or was the note kind of standard from the school? It's not from the teacher.
Oh, like the notes changed a lot. Like
Tell me
my
more.
last year teacher used to give like 2 thick stacks of booklets, and it included like a lot of information.
Doesn't help a lot for a Sec 3 student, right? Doesn't help a lot, right?
And it
Okay,
included like so many
yeah,
things.
So many things. It doesn't help studying, especially when you're grappling the basics. I understand. So the notes get better because the way I see your note just now, just by looking at that one page, I think your note is good.
Yeah, this year's one is like so much better.
Correct. And it feels that you understand it. It feels that you at least find some joy studying. Now, on Sec 3, the note was very bad. It's not a note, it's a book, right? So it doesn't help. The teaching,
I don't know. I think a lot of other people liked it, but I just couldn't understand her. Yeah.
Tell me more. What do you mean by other people like?
Like, I think I only found like me and a few other people saying that we didn't really like her teaching, but other people said they liked it.
The people who said they like it, I mean, a teaching style can be polarizing. It's not weird to hear that. I mean, but the people who said they like it, do they score like better than people who do not like it?
Yeah.
So it's very polarizing, really.
Mm-hmm.
Oh, this is a bit, oh, this is a bit rare, where it's truly polarizing. Do you care to share in a bit detail? What do you mean by some people like and some people don't like? Like which part is that?
Like, I don't know, I feel like she just like sometimes she went in like too deep, or like I don't know. Like she references her notes and her notes are like really detailed, and sometimes like because she updates her notes every year, then she adds stuff in between, and then there's like repeated stuff, and they're both different, and then you don't know which one to study from, and then it's like a whole booklet, and it's like yeah, it just makes it hard. But everybody, like other people, think that since it's so detailed, they understand it better. But I think it just made it worse since it was so detailed.
Ah, hearing you say that, I feel that you're saying that your secretary teacher was knowledgeable
Yeah,
and very willing to share her knowledge, lah. Like, just
yeah,
treating everybody as, the smartest JC student ever, something like that. Kind of.
yeah.
I see what you mean. Then I understand why it's polarizing. I understand. Anything else you want to share regarding Sec 3 Cat? Anything that you may feel is beneficial for me?
No, no.
All right. Then please tell me, the notes are an upgrade for you. Totally, I totally like that. How about the teaching style of Sec 4?
Yeah, I like it better because,
As in what? Yeah.
like, I mean, whatever she says makes sense, and I think she talks like she's teaching a Sec 4 class and not like, I don't know, like a JC student.
Or
Yeah.
a seminar, or something like that.
Yeah.
Yeah. Okay, let's say she, another lady, correct?
Mm-hmm.
Okay, your current teacher, she is more down to earth, let's say. Now, do you see the effect reverse? Like, people who dislike the Sec 3
Yeah.
one, and now people who like the Sec 3 one will miss the Sec 3 one lah. They
Yeah.
will feel that the Sec 4 one not so good already lah.
Yeah.
Okay, I understand. Now tell me then, Ria, the notes are better for you, right? The words she say, the explanation she give is also better for you, right? Thank you for sharing all this. I already understand what your class feels like also. Okay, this is very important. Some people have very good classes, some people have very bad classes. From the way I hear it, your class is in general good. The class itself is good. Correct or not?
Mm-hmm.
Okay, understood. Now, why the class is good, the teacher is good, better lah, yeah? The notes are an upgrade. How come you only give 5? What's what's going on here?
I think it's because there was no like test to see how much I actually, like grasp. So I can't tell if it's like
Correct.
I
It's very weird that you don't have any tests. It's very weird. It's extremely weird.
yeah.
Let me put it another way. Your project is a good replacement for the test, but only on one topic. Only on
Mm-hmm.
one topic. Which is, put it this way, if you see a battery question and the sister electrolysis, By right, if you do your project well, you will be able to understand them just very well also lah. That's what I'm aiming for. That's why I keep grounding you on the theory lah, right? Oh, O-level will do this, O-level. But only for that, no? Only for that. Anything else that you want to share regarding Sec 4 Chem?
No.
All right. I do this with all my students. I just do it with you a bit late lah. Then I understand your situation, right? Let me confirm one last thing. Your chemistry class right now is still among the worst compared to other subjects classes. Is that correct?
I mean, like I understand, but I think I can only rate it higher if there was a test.
Yep. I understand what you're saying. If the test confirms that you understand, then the class is actually quite good, right? Maybe the meaning of my question is I didn't make it clear. My point is, do you have the same trouble with other subjects, or only chemistry have this particular trouble?
Yeah, I think only
Good news to me lah. Then you can focus on chem. The reason why I ask you all this is because in this tuition, most of the time I encounter students who benefit from talking about other subjects. So in general, if they experience a lot of great improvement, it is spread between subjects. Very good for the O-level total lah. Did that make some sense? Like we talk about chem improve, right? Chem improve. Then we talk about A-math improve, talk about physics improve. Without adding the tuition time. It's just what happens after a while. So we end up improving multiple subjects, and that's a very normal thing that happens in this tuition without adding the time. That doesn't matter much, right? In your case, however, I believe that in this tuition, we should focus on chemistry. That one I believe so. Right? I believe that you shouldn't talk too much about other subjects. However, totally welcome if you want to ask about other subjects. That one I don't. It doesn't seem that you have trouble though. Okay, that's why I asked.
Like, do you talk about A-math? Like what subject?
Yeah, I talk about 5 subjects: A-math, E-math, POA, Chem, and Physics. Bio, if required, so I guess that's 6. But nobody asks 6 subjects, okay? People usually ask 3 or 4 subjects, and usually when their main concern are done. Because in the end, people come to tuition usually for one big concern, if that makes sense, right? In your case, your one big concern is very big. In other people's case, they do have one big concern, but 2 medium concerns, right? So they just look for the tuition for the one big one, and even though the concern is big, after a while, the concern is no longer big. So we just end up dealing with other problems to improve the overall mark, which is what happened a lot lah in the past years, right? Again, to answer your question, this tuition doesn't have a subject limitation. You can ask Chem, Physics, Math, E-math, POA, and Bio if you want to, right? But I do believe that your chemistry requires a lot of work. So I totally agree with focusing on chemistry. If you drop me a physics question right now, I'll answer for you. If you drop me an A-math question right now, I'll answer for you. If you want me to talk about A-math topics slightly ahead of the class, I will do that for you for half an hour or 1 hour. No problem. There is no subject limitation. That is how, let me put it another way. Sorry. Let me put it this way. There's a reason why other students of mine, even though when we talk about 3 subjects in 2 hours, 3 subjects in 1.5 hour, take turn, they don't feel that the hours are, too little. They feel enough. The reason is because even if, let's say, chemistry is problematic, right? And A-math is not, but it doesn't mean that the A-math is free of problem. First thing first. Secondly, for most cases, the A-math is not A1. It's A2 or B3 for most cases. We talk, improve it to A1 and shorten the study time a little bit because their AMAT is already good, good foundation, easy to build, get the benefit, then they struggle less with AMAT, right? Gain more, struggle less. And then they can dedicate more time to the problematic subject. That is in general the effect of discussing good subjects and make it excellent. There is no point in discussing an excellent subject, but there is a very good point in discussing a good subject. It will give you a lot of time in return. That is in general what happened. Fair warning to you first. Last year, I do have one student that focuses exclusively on AMAT. Yours are Chem, hers are AMAT for 3 hours. That is the only student who decided
like 3 hours at a
2 times 1.5 lah. 2 times 1.5.
Oh, okay.
So 2 days lah. 2 days, right? Not 3 hours straight. No, nobody. People die. People die. Nobody survives 3 hours. Man, nobody. So 2 days, 1.5, and I keep asking her, do you want to talk about your EMAT or not? Do you want to talk about your chemistry or not? Because I know she is a double science student, right? So take everything. And she kind of resists that. She does not want to talk about the other subjects. The other subjects are no problem. I totally believe that. That's not the point, you see. Even though there is no problem, you can still improve it and therefore give more time for AMAT in it. But she resists that. Now, what happened at the end in O-level? Of course, she doesn't get so bad. Her AMAT is B3. It's just that for 3 hours of tuition from Sec 3, getting B3 in AMAT is not the most exciting result, if you get what I mean. Right?
Yeah.
Whereas for the other students who just freely talk, hey, what's your problem today? We talk about it, Oh, I have a problem with AMAT. Oh, I have a problem with EMAT sometimes, a little bit, I have a problem with it. We talk, discuss, talk. They end up getting A1 or A2 across the board. You get what I mean? It's a 3 or 4 grade improvement across the subject because less time spent in one subject always benefits the other weaker subject, something. So I find in general, people who have trouble in one subject doesn't mean that he has to focus exclusively on that. I believe this is the first time I tell you all this, correct?
Yeah.
Now you know. Now you know. You know what? Just as a practice, is there any AMAT, physics, EMAT problem, maybe just one that you want to talk about right now? Just for, testing sake.
I think I have enough questions.
Yeah, just put one and then we'll talk about it and then let's end, let's end. Okay, you send me an AMAT question on right, maximum minimum. This is supposedly not a difficult question. So let's talk about it. Okay. Oh, sorry. Better go to the next page. Tell me, what's your problem? Uh-oh, okay, Jamboard error. So tell me what's your problem. Okay. Yes, you're saying? Sorry, the picture disappeared. Sorry. You're saying?
I think there's something to do with similar triangles to find the volume, but I don't know if that's correct.
Okay. Now, let me confirm a few things with you first. In this kind of question, the first part will appear, the first part, the show part, right, will appear hard and new every time. Sometimes not too hard, but definitely new. Okay. Whereas the remaining part is gonna be easy, almost standard. Easy and standard.
Yeah.
Kind of easy to figure out. And you're saying that you have no problem with the part 2 and part 3. Let me confirm that.
Like
Good.
eventually I would get it, but
Oh,
yeah.
eventually. Okay, I don't like eventually. Okay. But for now, let's talk about part 1. That's fine. Part 1 has a totally different approach to part 2 and 3. You at least know that already, correct? You know that already. I'm going to label part 2 and part 3 A math because differentiation, right? Differentiation. You know that, okay? If you need to make it faster, we should, because this holds a lot of marks for comparatively little effort. Yeah, this maximum minimum question is always a lot of marks for comparatively little. We'll talk about it next time. Now, this hard and new one, I will label it E math. It's not A math at all. It's E math. And you're right, it always deals with triangle. That's their favorite subject. Now, a favorite shape to deal with. You are right. Now, you already mentioned similarity and congruence. What other triangle methods do you have in EMAT? Let's collect them first. Similarity, and then?
Pythagoras.
Pythagoras, correct. Sometimes that happens. And then one more. Tokaso. I mean, simple stuff, right? So, and then one more is a general mensuration. General mensuration will be in your email. Now, let me talk about part 1 now. I promise you this. It is only email, nothing else. Even though it's hard emath, it's just emath. It should give you, how to say, hopefully this should give you an idea that it shouldn't be that hard. Okay, now let's talk about it. But to be fair, this is harder than expected, right? Okay, so now, do you know that it's 90 degrees? This is 6. What is this? Sorry, I cannot see. Abigail, again. Okay, R. Okay, R is unknown. H is unknown. Yeah. Oh yeah, definitely similar triangle. Okay, how do I know? 90 degree, 90 degree. Again, similar triangle proven by what? EMAT. Similar triangle is proven by AA. That's the easiest principle, correct? Two angles. This is 90 and this is 90. And here's your common angle. Common angle.
Yeah.
That the two triangles are similar and you are supposed to use them. So when you use them, again, EMAT technique is to label A, B, C, and then let's call that DE. Just easier for us, okay? ACB, triangle ACB is similar to triangle ADE, based on AA, correct? Again, notice that I label it as A and then C with D, and then B with E. Notice that I should be writing that. Clear?
Yeah.
This is the first thing you must write now. Do you realize this similarity before I tell you?
Yeah.
All right. Then your problem is to use it. That's a comparatively easier problem. Show me how you use it while I talk to Abigail. Okay. Abigail, I've seen you. Yeah. Can you hear?
Yes.
All right, Abigail. Abigail, type something wrong. Tell me, Abigail, what's your update today and what do you want to talk about today?
Oh, I got back my AMATS paper today, so I think we can go through it.
Very good. The easiest thing is to just take picture of every you're working because I want to see them. Could you send me through WhatsApp? Let's do that first. And then you can slowly put it in what you want to talk. Okay. Send me everything. You just have to discuss what you want. No problem.
Okay.
Ria, are you stuck in the, thank you very much. Ria, are you stuck in the using the similarity?
Is it like R over 6 equals to AC over D?
Uh-oh. All right. Okay. I'm gonna redraw the ACD, right? Okay. ACD. That's not it, right? So I flip it like that, and this is a 6. And the problem is I do not know this and I do not know that. That's a problem. Compare it with the big guy. The big guy is, this is R, this is H, And that's it, I believe, right?
Isn't
Yes.
H this?
I am so sorry. What am I talking about? That's the H. Yeah, so sorry. That's the H. So your problem is I cannot. I will do this. If I have the R of a H equals to 6 over I don't know. This is part of the problem, correct? That's the problem.
Mhm.
Now, is it possible for you to figure out one of the unknowns? That's the mystery here. I'm hinting you slowly lah. I'm hinting you. Is it possible? Because I've seen it already. It's quite obvious to me. It's quite obvious to me. It has something to do with the sphere. It has something to do with the sphere. Small hints. Okay, Abigail. Oh, goodness me. Right. Okay. Yeah, that part. Yeah, that part. Your completing square is bad. Okay, I understand. Oh, the cert end up being good until the end. Good. I like that. Simultaneous equation, very good. Very nice handwriting. The other cert is very good. Okay, I understand. All right, Abigail.
Sorry, but can you help me upload it to the Jamboard? I'm having like trouble doing that. I already
Okay.
show you the Jamboard. It's called Abigail Amets WA1.
Okay. Now, normally I cannot do that when things are crowded, yeah? Okay, normally you have to do it, but right now, today, I think I can. Now, which pages do you want to be uploaded?
Like, let me check.
Okay. Before that, I'm going to talk to Ria first. Ria, no idea?
No.
Then for now, I will just give you something. This is the last hint. The moment I do this, the question becomes easy, right? The question becomes easy. Now, this is 6. This is also 6, isn't it? Correct? Am I correct? And therefore, this guy is H minus 6,
Okay.
which kind of makes it now very easy to do. That's what you need. This is the thing you need. Kind of spoiled the question for you. Kind of spoiled the question. Okay. Now, just from this simple exercise, Ria, I feel that your AMAT basics are strong. Definitely requires improvement, but definitely stronger than chemistry. Definitely. Can you do this by yourself now?
Yeah.
Feel free to stay if you want to, but if not, feel free to log out also. We can continue next time, right? Okay. Okay. So Abigail, question 4A, question. Now, Abigail, I have no problem discussing those questions. I do realize that most of them are the discriminant part. The quadratic part is the one that troubles you a lot, right, Abigail?
Yes.
And the quadratic part, no matter what, even though we discuss some, we didn't discuss enough, I suppose. We don't.
Yeah.
Now, let me tell you something about the quadratic, Abigail. I'll tell you one thing first.
Yes.
There is no practical point in discussing them right now, but there is a moral and mental point. Psychological. Let me explain first before we spend time. You must understand because you don't have much time. You only have 1.5 hours. Now, what do I mean by no practical point? In O level, the discriminant and quadratic question will give you at least 4 marks, at most 5, So 4 to 5. Let me do a comparison with CERT. CERT will give you at least 4, at most, I've seen 7 but 7 is better. So I'll say at most 6. CERT, 4 to 6.
Okay.
Polynomial, you're currently studying polynomial, correct?
Yeah. Oh, I'm at
Polynomial?
binomials now.
You're in a binomial, yeah, even more important. For comparison in binomial, I feel binomial is much easier to understand than the quadratic. And it gives you at least 6 marks. At least 6 marks.
I agree.
For comparatively less effort. Really no. In understanding and in doing in exam. I'm talking about the final O level. I know. Quadratic chapter is a very weird starting chapter. It feels it's supposed to be easy, but it is not. It's very difficult to understand. And surprisingly, it doesn't get used too much beyond that chapter. Very different with Indis. Indis get used quite a lot beyond the Indis chapter. So Indis kind of important, quadratic kind of a bloody waste of time. That's the practical point of view. Understand?
Okay.
That's practical. Now, mental and moral. It depends on you what is the point in discussing them. But if the discussion reason is something like this, I did badly in this exam, so I better correct it for the sake of the next exam. That doesn't work very well practically. The next exam does not use too much quadratic, for good or for bad. It uses a totally different thing. Binomial doesn't use quadratic. Polynomial use so little quadratics. Search doesn't use quadratic too much. Logarithm doesn't use quadratic at all. You get what I mean? It doesn't use quadratic. It's a very weird starting chapter. It's very weird and impractical one. You get what I'm saying?
Yes.
You, Abigail, in this tuition, as with everybody, you must decide how to use your time. Do we talk about quadratic or not? That's my question to you. If you are confused, tell me and I'll give you more consideration so that you can decide that.
I'm kind of confused.
All right, then let me tell you more facts. Just now, I'm telling you that discussing quadratic may help you feel better, but it doesn't help you in the next exam. It doesn't even help you in the current chapter. That one's clear, yeah? That one, there is no confusion, right? Let me put it another way. Abigail, if you can sleep without talking about your quadratic mistakes, then we don't discuss about it.
Okay.
If I see your cert, because I really read through that, I saw all your problems are mostly quadratics. If I see that your problem is in cert, I have more tendency to talk about it than the quadratic mistake, even though there's a lot of quadratic mistake. Because at the end of year 3, the quadratic will have been reduced to a smaller proportion. There will be much bigger proportions of other things. This kind of major mistake loss, blah, 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 only happen in WA1. I mean, currently you're doing WA2, so that's fine, But term 3 and term 4, not going to be like this anymore. If you already done the correction, if you can live with the correction, if you can sleep knowing the fact that you still haven't improved in quadratic, my quadratic still not so good lah. Yeah, I agree with you. Doing correction doesn't help. Discussing with me might not help. If you can sleep with that knowledge, let's talk about the other topics. Is what I'm trying to say. Am I making you more confused?
No.
What is your decision, Abigail? It is still back to you. You decide.
Okay, I just want to discuss I just want to discuss 2 questions then.
Sure thing. Make a choice.
Hold on.
I mean, to be fair, I'm very unhappy with your mistakes, but practical side of things, it won't.
I just for question 1A, right? How can I tell?
Doesn't matter too much. I'm not saying that I'm happy not discussing linear, but I know what's going to happen in the near future. So Not these things, not these things. Not inequalities and not quadratics.
Okay, then.
Yeah, so choose your question. Choose your question. I don't mind. I still don't mind talking about it. Zero. I mean, I'm chiefly unhappy because I know you have put in your effort. That's the reason why I'm unhappy, because I want your effort to feel fruitful, right? That's what I want, right?
Okay, then I just want to discuss a question. Oh, it's on page 2. Like
Page 2, which is, sorry, which one is that? Sorry, which one is page 2? The B, the B, is it?
A. A.
A. Sorry, because I have no idea which one is page 2. It's not 1B, right? It's not 1B. So which one is page 2? Sorry, what is the number of the question? Is it 1B? Is it 4A? Which question?
It's page 4A.
Okay, 4A, right? 4A. Okay. 4A. Let me confirm. Express the 2x squared minus 4x thingy thingy.
Yes.
Completing. Right. Okay.
When you told me like your method, right,
Yep.
for the like an easier way of doing this instead of just like completing the square, I
Yep.
find it that it's kind of inaccurate for me. Like sometimes my answer is off by like the end of the equation. Like all like my numbers are correct, but like my sign is wrong. Like it can be like plus or minus. Then I'm wrong there.
Sorry, Abigail. You're talking about my method or the teacher's method?
Your method.
Okay, but you did your teacher's method in exam, right? That's your teacher's method, the completing method. It's totally gone 0 mark.
Yeah.
So what's the comparison here? When you say my method works very well, as in depending on the practice, yeah, are you saying that it also gives you 0 marks? Because this is 0 marks. This is like so bad.
Yeah.
It's really, really, really bad, right?
Yeah. I kind of forgot.
So what do you want right now? From a practical point of view, I'll give you the advice. I'll give you the facts first. A practical point of view, completing square does happen in EMath. That's one. And they have a very specific use in EMath. To be fair, completing square is useful in EMath and AMath. To be fair, maybe it'll give you 3 marks in both exams. To be fair, there are some practical uses. Now, what's your angle here? Do you want to be able to do at least completing square? Is that the angle here?
Can we try to do this question but with your method?
Okay. My method goes like this. Let me repeat one more time. Teacher's method goes from here to here, correct? That's the teacher's method, correct?
Yes.
My method goes the reverse, and I claim it is just way better, especially when things are hard. So I go the other way around now. So what do I do? Yeah, in your teacher method, you have to, so to speak, complete the square law, right? Complete the square. In my method, I never complete the square. I simply expand. Make sense? I simply expand. Which is, I claim expansion is easier than completing the square. That much I think is true. Can you expand Abigail for me? If you don't know expansion, tell me right now.
Expand which one?
Again, Abigail, the logic, the logic first. Going from here to here is what you usually do with the teacher. Forget about that. It's starting from here. That's my method. If I start from here, I'm telling you expand this guy. Now, is that doable or not? Expand that guy.
Yes.
All right, then expand that guy first. That's the starting point. Other than that, it's very easy. I want to see you expand that. Okay, I'm gonna cancel. I'm gonna stop. Abigail, your quadratic reveals a lot of weakness from Sec 2 and Sec 2, yeah? This is something that you must live with lah. Your Sec 1, Sec 2 math are terrible. Terrible in a sense that it gives you a weak foundation, but you are not terrible. Your math is terrible. You are not terrible, you can learn. So learn with me, yeah? When you put in A inside, you're immediately wrong. I won't explain why you are wrong, but you're putting in inside is totally wrong right now for two reasons. It's wrong conceptually. Secondly, it's making your life harder. That's a worse mistake. You don't get any benefit at all by putting the A in first. You should simply be expanding the X plus B. Don't put in the A first. You're just making your life difficult for no reason. Do you understand what I'm saying? That's the biggest mistake. Do not erase. Just redo. Just redo. And you will have a comparison about how much easier it is.
Okay.
Right. Right, you got expansion and then put the A and then plus C, right? Okay, now
Yeah.
expand one more time and then we are almost ready to do the final step.
So I put A in like this.
Inside. Now you put A inside. Yeah. Now it is true that you have to do this. It is true. But now not at the start. Definitely not.
Okay.
Okay, good. Yeah, okay. Careful there. Now, let's stop here for a while. You're doing great. Now, I find it easier for you to do it as 2abx. Do you understand what I'm saying? It's just easier.
Yes.
Okay. Now, conceptually, you gotta see this separate from this, and this is combined. Do you understand what I'm saying? This is the part that you sometimes struggle with. Do you understand that we should keep them separate? That is.
Yes.
The AB squared plus C combined, you have no problem at all. Let me confirm.
Wait, can you repeat that again?
One more time. AX squared is conceptually separate from 2ABX. That one, everybody have no problem. Okay, everybody no problem. I want to confirm, however, that conceptually, AB squared plus C should be viewed as a unit together and separate from the rest. Do you understand? Why?
No.
We may wonder. One more time. Let me explain. This is x squared. Oh, you understand? Sorry. Okay, you understand. Sorry, you understand? You understand? Because there's a requirement for this technique. The requirement is you can see them like that.
Oh. Yeah, I understand.
I'm not. Okay, good. Now, things are going to be very easy. Now, this is my promise. My promise is the expansion is not difficult if you done properly. And then after expansion, things become easy if you can see them. Now, let me show you why. Put that here. Put it here. Okay, I'm dealing with the first guy. The first guy is here. I'm going to use a different color. This is the first guy. So immediately, A is 2, look. Correct or not? This is just immediately correct already.
Yes.
You understand? Okay, good. Then this whole thing is minus 4. But A is already 2. So B is going to be equal to, it's going to be very easy, right? -1. Done. Correct or not?
Eh? How?
One more time. 2ab is -4. Can you see that? 2ab is -4. Can you see that?
No.
Why can't? Why can't you? I object. 2x squared, ax squared. So a equals to 2. 2abx, the comparison is -4xy.
Oh, I
That's the
see it.
comparison. Good. You need to see it. This is a very standard polynomial strategy, which is why my method is slightly better because it uses a very similar strategy to polynomial chapter, which has more marks than quadratic chapters, you know. Let me just put it in a very practical.
Okay.
So do you see that b is equal to -1?
Yes.
Therefore, the last thing is this whole thing is equals to 3. Correct or not?
Yes.
But you know a is 2. You know that b is -1 square, and therefore c is so easy. C is just equal to 1. That's it. Correct or not?
Yes.
Now you check it out. A equals to 2 according to my method. B equals to -1. C equals to 1. Hey, look at the answer. Correct or not?
Yes.
Correct, right? See? Why so difficult?
Oh.
Why so difficult?
I don't
Nothing.
think you've ever taught me this before.
I certainly will not teach you completing square. I have made it a point not to teach my student completing the square.
Okay.
I certainly will not teach my student completing the square. Now, do this method for the second one. Do it. What's the benefit? You already expand. Did you see that? Hey, already expanding. Very easy one. You just have to do the comparison. Do it in the next page, and hopefully you get it correct. Okay. At this point, you now do the comparing coefficient, a standard method for polynomial. Compare and should be fine. Okay, that's done. Okay, a very nice comparison. So Abigail, what are you talking about? What is a equals to -4? What's that?
Actually, can you like, explain this part again?
What is going on here? Are you certain that this is -4? Let me confirm. Are you certain?
Yes.
Good. -4 equals to 2ab lah, basically. Do
Yeah.
you have the a?
-1.
Which you get it because you are doing it the easy one out, which is totally great. You should do the easy one out. If you have the a, is it that difficult to get b?
No.
All right, then do so. What is going on here? What is going on here? What is going on here, Abigail? This whole thing is -4. You are correct. You're absolutely correct. The a is -1, which is you're also absolutely correct. Why do you write these weird things? What is this, man? Are you using some sort of formula in your mind?
No.
Are you saying that b is equal to 4? Is that what you're saying? -1 times -4?
Yes.
2 times -1 times 4. What is that?
-8.
Which is not -4.
Oh. Oh. Oh.
I want you to use logic, Abigail. I want you to use your logic and common sense, yeah, not formulas, okay? What is
Okay.
b? Stop erasing it. Don't erase. Don't erase. Just leave it. Just leave it. Just redo.
2.
Yes, you are correct. It's 2. Never mind the presentation. As long as you're correct, that's fine for now. Last one, C.
Eh?
Let me confirm one thing, Abigail. -4 plus 7 is 3.
Yes.
Your answer is C equals to 7. All right. Don't know whether you're right or wrong, right? Just compare it with the answer kilo. Are you correct?
No.
Oh, because you copied the wrong question. Look, you copied the question wrongly. Yes, you are.
Oh. Whoops.
Okay, just fix the, don't erase everything, okay? Stop. Just fix your mistake, lah, right? Okay, good. It's not +5, it's -5. Come on. Okay, yeah, -5. Yeah, -5. Come on. It's -5. It's not 5. Hey, come on. Okay, thank you. -5. All right. So you just have to adjust your answer. Shouldn't be that hard. Abigail, -4 minus 1 is -5. I guess your answer makes sense. Are you correct?
Yes.
Now, we spend 20 minutes on all this. What is your conclusion?
Um. I got it now. What are you doing? Oh, no. Can I help? No. No. Okay. I understand it now.
Yeah, intuition, but beyond tuition, do you have some sort of change of preference? I guess. Next time, next exam, next whatever, EMAT, AMAT. What do you think?
Think what?
I mean, if you understand my method, does it mean that you simply need to improve the teacher's method so that you can do the teacher's method? Is that the effect of these 20 minutes?
No. I'm
Then
going
what
to
is you're going to use? Sorry, you're going to use what?
I'm going to use this method from now onwards.
Right. Now let me clarify a few things to inform your decision. I've seen no teacher teach this. Almost none. In fact, I've never heard it from my student. Right?
Oh.
However, I can confirm a few things with you that this will not be penalized and this is valid. This is a totally valid method. How do I know? Polynomial uses the method. Pretty simple.
Oh.
It's not even a new method. It's just borrowing from polynomial. And you know that polynomial is cubic, right? Cubic is more complicated than quadratic. If it works in cubic, it should work in quadratic. You get my point? There should be no penalty, and indeed there is no penalty. But you will never see a teacher teach this. Okay, so I'm going to clear with you first. If you use it in O level, you will be fine because polynomial allows that. Okay,
Okay.
I think the reasoning is quite solid on that. Now, I want to explain why teachers don't teach this in quadratic, even though they strongly teach this in polynomial. They will favor this method in polynomial, and many other chapters after this. Surprisingly, they favor this method like in all other topics except for quadratic. It's a bit crazy if I think of it.
Okay.
Let me tell you why. The reason is very simple. Here is an 8-lane highway. Have you ever seen an 8-lane highway?
No.
Wait, you live in Choa Chu Kang, right? So you live in Bukit Panjang, correct? Something like
Yeah.
that?
Yes.
Oh, Bukit Panjang don't take highway one. Okay, never mind. In Singapore, there exists a lot of 8-lane, 10-lane highway. It's impossible that you have never seen one. If you take a bus that crosses the island, most of the time that bus will take a very big highway, like a very wide highway where you just see a lot of buses and they're speeding very fast. Okay?
Yes.
So 8-lane highway. The reason why the teacher's method is because when you're good at it, you are faster. Okay? But here's the problem. It is fast if you are able to dodge all your bus, truck, and car through the 8-lane highway. You're crossing the street of an 8-lane highway. As you have mentioned, one mistake in minus, you are gone immediately. No marks at all. Correct or not? Mistake in minus, mistake in quadratic, mistake in fraction, mistake in anything hits you, you are gone. It doesn't matter if you manage to cross here. If you make one mistake, you are still gone. It's so bad. That's the teacher's method. If you're very good, you're faster. The problem is, I don't think we should do that in exam. I don't think you should cross an 8-lane highway in exam. Let's compare that with my method, which is not my method. It's just the other topic's method. Oh, for goodness sake. My method is simply go to the overhead bridge, take some time, go to the safe route, and walk to your school safely. It may be raining, it may be on the sun, it may be very hot, but it's very safe. It took a little bit more time and you will almost certainly be correct because you're not dodging 8 lanes of buses and cars. So it is so simple. Plus,
Okay.
it's so standard one. It's very easy every time it is correct one. The 8-lane highway, I mean, can't really say that. Okay, so that's my facts lah for you. I agree with your decision because I know what's going on. Hopefully, you will be very happy once you see the result in exam. Okay,
Okay.
right. With that in
that-
mind, you're saying?
That's all. Anyway, my class is like starting on logarithm.
Logarithm.
Yeah, so we can go through that.
Okay, Abigail. Now I gotta talk about something here. Yeah, gotta talk about something. Do you want to continue with your AMAT beyond Sec 3? Because you know there's an option to drop. I gotta ask this right now.
I don't know if my school can drop it.
Let's make the assumption that you cannot drop, so you have to continue. Then I change my question. No? I change my question. What is your minimum score at O level for AMAT so that you are happy? I really mean happy. Abigail, happy. What's your minimum score for AMAT?
B3.
B3 makes you happy. B4 doesn't make you happy. Let me confirm that. B4.
I mean, B4 is fine.
But B3 makes you happy.
Yeah.
C5 is not happy at all. Let me confirm that.
I guess.
Okay. B3 makes you happy. It doesn't have to be A2. A2 is better lah. A2 is very happy. Let me confirm that.
Yeah.
Okay. Right now, you are very far from B3, but you know that already, right? It's not because
Yeah.
of quadratic. It's the way you treat the topics. Or rather, maybe the way your school teaches it, maybe it's a combination, I don't. But my AMAT student always studies the topic before the class. And then the class makes sense and then they can do the homework. You're not doing that. Partly because you are dividing your time. Okay, that's one reason, right?
Yeah.
Let me give you another facts. You take 8 subject total. Am I correct? You should be like 8, right? Let me see. EMAT, AMAT, Chinese, English, right? That's 4 already. And then
Yeah.
2 sciences, right? 2 science. Oh, science is combined, is it? So combined science, that means that's 5 lah. Combined humanities, that's 6. You're saying?
I still
You're
have to
saying.
study for like, even though it's combined science, I still have to like study for both subjects. So
You are correct. A combined science problem is that the study is like in total 1.5 subject, like it's like 1.5 pure. It's not that simple.
okay.
The advantage is that the exam is easier, but the study time is longer compared to just one pure subject. That's a fair assessment, you know. So let's call that 2 subject for now. That's fair. You know what's going on. So AMAT, EMAT, English, Chinese, right? Then chemistry and physics, I'll just consider them two subject. And then combined humanities, I'll consider them 2 subject also, right? Anything else?
Yeah. POA.
Oh my goodness, you take POA also.
Yeah.
Oh, Abigail. Yeah,
No,
yeah.
my school
Yes, your school.
forces me to take POA, so
What
I don't have
does it know?
any other option.
Oh my goodness, my headache. Okay, like this, Abigail. Okay, like this. Listen to me.
Yes.
In this tuition, you get to ask many subjects, right? Many subjects, right? And most of the time, you are concerned with physics and AMAT. Am I correct? Those are the 2 things, right?
Yes.
Your EMAT is fine, which I'm very happy. Okay? It shows that you do have talent in math. That's why I'm not frustrated with your talent. I'm actually frustrated because your talent is enough. It's just that the study is currently not doing it justice. Your talent is in, right?
Okay.
And since you're AMAT student, technically POA will be a walk in the park if you could just know how to do it. In this
Yeah.
tuition, I talk about there's a possibility of talking about 6 subjects. Just telling you first, AMAT, EMAT, the triple science, and POA.
Yeah, I heard you talk about it before.
You talk about it. Yeah, correct. Right now, to achieve B3 in AMAT, to make you happy, 1.5 hour every time is probably not enough, or probably if we keep doing that, you will finally catch up with the class by the end of Sec 3 if we do it all the time. Amen. That's the fastest that you can do.
Oh.
Partly because it is influenced by your foundation, or a bit weak from EMAT. So we gotta fix that, which is a good thing, fix, and then end of Sec 3, you catch up with AMAT. That's 1.5 hour, my guess. Okay, I think that's a fair assessment. I could never teach you AMAT properly, never. For example, I teach you this method after the exam. Like, okay, that will be useful for you at the end of year if you don't forget. So it is not helping you in exam. It's just helping you correct after the exam. Doesn't feel so good.
Yeah.
Then binomial. Only teach you a little, and then we have to shift to that topic already. Your binomial is nowhere strong. My students already do the exam level binomial before the school starts teaching binomial. Then they're okay, something like that. You should experience that so that you know for yourself, your talent is enough. If you just have a proper study approach, AMAT is not giving you too much of a problem. It shouldn't be. But right now, it's giving you too much of a problem because the study tempo is not good at all. Okay, those are the facts. I'm not scolding you. I'm telling you the facts. Compared to my other students, that's your problem. Okay, not your talent. Your mind is fine. Your talent is fine. Your hard work, probably okay. Probably enough. I mean, I'm really surprised that you take POA, but besides the point.
No.
But you're saying, right? Yeah, you don't have a choice.
Yeah.
But with this kind of approach, you will not enjoy AMAT. It's gonna get worse. We gotta talk about AMAT way earlier if you want to enjoy it.
Okay.
Do you want to enjoy it? To see that you can do it? Do you want?
Yes.
Then we must do what I do with my other student. We must. And you will immediately enjoy your class better. Immediately what? You don't have to wait until the end of it. Okay? Right? At the expense of other subjects, if it is only 1.5 hours. At the expense. Okay? Plus, I will still ask for a bit more extra in June. I will still have to do that because 1.5 hours is in general just not enough. However, it will pay back to you multiple times by simply showing you that AMAT can be done. It can be done. That's a promise. Okay?
Okay.
Right. If you want other subject, add more hours for now.
All right.
Now, with this, I am assuming that AMAT is your priority in tuition. Is that the right thing to do, Abigail? I just want to check first. Is that the right thing to do or not?
Yes.
All right then. Now tell me, has your teacher started logarithm or still not?
Just started just at the introduction part. She's not even done with that yet.
Okay, so now a few things to run faster than the school. we gotta talk about your textbook. Your textbook is in general good if you haven't started the class. After you start the class, it becomes just so-so. Do you have your phone holder thingy? Oh no, you do. What's the problem again? Tell me a problem with phone. You have a lot of technical problems. Yes, problem.
My phone, the resolution is too.
The camera. Yeah, the camera. You have a camera problem. Yeah,
Yeah.
no, I remember. Plus, you don't usually bring your textbook home. Am I correct?
Yes, but I can bring it home if I.
Okay. Now, you, Abigail, as far as I can tell, you are the type that can rely on textbook and will probably need to. Okay. If I just start to explain logarithm without the grounding of your textbook, you will be lost. So that's the second requirement. We have to talk faster and we have to talk by helping you understand the textbook. It works very well for most students anyway. The textbook is very good if we are talking about it in advance.
Okay.
Okay. So you gotta have your textbook. Thirdly, you gotta solve the camera problem, which I gave you the tablet instead, right?
Yeah.
Now let me think for a while. Okay, I'm gonna show you what it means. I'm gonna spend 10 minutes explaining logarithm for you, and I don't think it will be very comfortable to you. If I'm wrong, I'm very happy. If I'm wrong, I'm very happy. So let's try. Trying to make a. Okay, logarithm. Here's a fair warning on logarithm. Logarithm will give you 4 marks to 6 marks in O level. In your next exam, at least it will give you 4 marks times 2, which is quite a lot. So they kind of make a big deal out of logarithm because logarithm influences two other topics. One is called the linear law. Of course, you don't know yet. And the other one is called the integration. This is in Sec 3, and this is in Sec 4. So logarithm is a big deal by itself, and logarithm will also be used beyond logarithm in that sense, right? So logarithm is a big thing. That's, I guess, the motivation to study. Sorry, let me confirm you take physics. Okay. So linear law will also benefit physics practical. One more time, Logarithm has an effect on your physics practical through the subject called linear law, because linear law is used extensively in physics practical. Just say. Okay, clear? So far, so good?
Yes.
Now, logarithm. Now, that's the good news if I will say that's the motivation. The bad news is it is almost full memorization. This is the bad news if you don't like memorization. Meaning, it is very difficult to truly understand the equation. Okay, it's difficult to understand the equation. For example, the method I teach you just now, the method that I claim is just a standard method in polymer. It's kind of easy to understand the method. Am I correct?
Yes.
Compare it with the teacher's method, comparing the coefficient, completing the square. To be fair, completing the square not very easy to understand lah. Correct or not? It's not that easy. And that's why you don't like it, right? Not a lot of people like it. Those who understand. For those who understand, do not understand. Logarithm, in general, belongs to no matter what, it is difficult to understand. No matter what. However, unlike quadratic, we cannot ignore it. We have to face it. All the more, most of the time, I teach way ahead because memorization requires time. Now, we're trying to gain this time. Okay, now let me show you something. Logarithm have a base here. This is called the base of the logarithm. And there is a number inside. Okay, there's a number inside. So for example, the base can be 2. You do not know what that means, but there is a number there. And inside, there is another number, 10, for example. Now, this is what a logarithm looks like. Logarithm base 2, 10 is how we read it. You do not understand what this means. Just stay with me for now. You understand? So far, so good?
Yes. Yeah.
Let me show you immediately what logarithm means. This is not what your teacher teach. Most teachers do not teach this. I teach this because this is the only reasoning in logarithm. I teach it differently, this basic. There's only one basic which I teach you different from the teacher. I teach you differently because, again, easier to understand. Okay? The things I teach you, I always try to make it easier to understand. Now, what is the purpose of logarithm? It is to reverse in this. To reverse in this or to cancel in this. That is the point of logarithm. What is logarithm? The reverse of index. What is logarithm? The cancellation of index. Let me show you what it means. Give me a random number.
3.
So currently I have logarithm with the base 3 and then inside there is something else. Let me confirm one thing with you. This is not a times. This is not times. Can you accept that? That is not a times.
Yes.
It is just logarithm base 3 something, no, whatever logarithm means, whatever. I'm going to show you something inside. The inside can be 3 power 2, for example. The inside. Inside, you notice that this is an index. Am I correct? Power
Yes.
lah. And an index always have a base, correct? The base, and then always have the power also. And this is very simple, but the base and the power. This is the base of the index, and this is the base of the logarithm. There are two bases here. Am I making any sense?
Yes.
Immediately, this is equal to 2 without any thinking at all. Without any thinking at all, this is 2. If you understand this is logarithm. Why? Because the base of logarithm is 3 matches the base of the index. When this happens, the logarithm and the index, so to speak, cancel each other, so to speak, reverse. Logarithm reverses the index and they disappear, giving you 2. That's the function of logarithm. By matching the base, you can do this. Clear? Now,
Yes.
I will do the reverse. The reverse looks more confusing. That's why I have to show to you. This is now 3. The base of index. There's a power here, correct? Base of the index, correct?
Yes.
I put in the power logarithm base 3. Wow, so weird, lah. Base of the log. So weird. Base log. And then inside, I'm going to put something else. Give me a random number.
7.
7. Do notice that this 7 does not have base 3 lah. That doesn't matter. What matters is this is the index, the base is 3. This is logarithm inside the power, the base is 3. Oh, they matches. If logarithm cancel index also cancels logarithm. It's that simple. So what happens? This is immediately equal to 7 without much thinking. Logarithm cancel index cancel logarithm. That's the function of logarithm. Do you understand what I'm saying?
Yeah.
Now, let's practice this immediately. I want you to write a version of this. Slightly different one here. This one, a slightly different one here. Please write something like this. Okay, base 4 logarithm. I'm gonna give you a test. Okay, I'm gonna give you a test. I'm gonna give you 16. Okay. The base of the logarithm and the base of the guy inside is different. Am I correct? They are different.
Yes.
If they are different, technically you cannot do anything lah. Technically, until you realize you can apply your indice here. If your indice is weak, it will be exposed in logarithm. You have to use your indice in logarithm, right? So be prepared. What can you do to 16? 4 power 2. You are correct. And immediately the answer here is, and you would be correct. Thank you. Congratulations. This is correct. Do the other one. Okay, we have a problem. In this base is not the same as the base of the log. Can anything
Yes.
be done? Can anything be done? Right? Oh, the answer is cannot. It's gonna be difficult. Yeah. Oh, and first of all, 9 is not 3 power 3. Come on. See, you're in this still problem. But never mind. You do what you want first. Then I'll show you why it's gonna be a bit weird. Okay. Okay, I'm gonna continue from here. Okay, I'm gonna continue from here. This one's fine now. Now I'm gonna continue. This is 3 power 2 times log 3 base 8, correct? So far so good? This is how indice works. This is indice, not logarithm. Do you understand or not? Tell me. Yes?
I understand.
Good. Now these two will affect your basic logarithm and indice cancellation. The two affects it. And now the good news. That just now was the bad news. The bad news is, hey, oh my goodness, I cannot do this, right? But the good news is the logarithm have 3 laws. 3 laws that are not easy to understand. They are to be memorized. What I taught you just now are not the laws. What I told you is just the meaning of the logarithm. The meaning of logarithm is to cancel it. One of the law will allow you to deal with these two and therefore allow you to do this. Okay, I promise you I will be teaching you the law and then you will be able to handle this. So far so good? For now, this is a pause. Let's pause for now because of the problem of the two. Now, let's go to the next page and I'm going to teach you your calculator. I'm going to show you something regarding your calculator. Take a picture of your calculator, please. Send it to
Sorry,
WhatsApp.
can I go to the toilet first?
Yes, please.
Hello, I'm back.
Mhm.
I already sent a picture of the calculator.
Just a minute, yeah. Okay, I'm putting it in your Jamboard. Okay, good. Let me confirm your teacher haven't shown you the logarithm option in your calculator.
No.
Okay, there are only two options. So your calculator is limited. Your calculator cannot do different base, only two bases. That is the traditional limitation of every calculator people can use in O level. In A level, depends. Depends. In A level depends, right? So the only two logarithms are here. You look at the Jamboard page 6, yeah. LOG is actually log base 10 something. LOG. And in textbook, written as LG base 10. So this button here is confusing because it's logarithm, but no base. There is no such thing as logarithm without a base. There's no such thing one. There is always a base in a logarithm, and the base is inherently 10. Logarithm base 10. In textbook, they write down as LG. Don't ask me why. So this is LG, which means logarithm base 10. Would that be okay so far?
Yes.
How do I know? Look at the guy inside. The guy on top is 10 power. So this tells you two things. See, logarithm is the reverse of 10 power. Power in this. It is what? Logarithm is the reverse of power, and this power is 10, base 10. So the logarithm must be base 10. Okay. If you look at your calculator button, sine and sine inverse are together because they are reverse of each other. These are reverses. These are also reverses. Tangent inverse are also reverse of tangent. Square
Okay.
root is also a reverse of the power. The calculator is done in a nice way. Now, the other guy is ln. ln is actually logarithm base e, which is something totally new. This is a totally new number to you, isn't it? What the heck is this? E power 1 is equals to 2.71 something something something. This is called a natural number. They will not tell you the history. They will not tell you why this number exists. They will not tell you why this number is important. The fastest you will learn why this guy is important is at an engineering course in university, maybe year 2. That's very far. From now on, until JC2, if you decide to take further math, they will just treat E as, hey, it's a number lah. It's an important number, but I don't tell you why it's important. It's a number, just like pi.
Okay.
Can you accept that for now?
Yeah.
How do I know ln is logarithm base E? Because there you go. There, this number, E. There you go. Yeah, E. Now, please press your calculator. Use E power 1. Just show to yourself that this is a number. E power 1, please.
Yeah, I see it.
Good, good. Now, therefore, now test your calculator lah. Press the LOG button because LOG means base 10, correct? Correct or not?
Yes.
Put inside 10 power 5. Just try. What is the result? Okay, why so
5.
slow? 5. I told you, right? The function of logarithm is cancel base. Just to confirm, if you replace this as 8, it doesn't work. Just checking first, just checking. It's gonna be less than 4, I think.
It's about 4.51.
Something like that. Something. You get the
Yeah.
point, yeah? It works when the base matches. When the base doesn't matches, it gives you ugly number, right? Now, has the reverse though. The reverse is 10 power logarithm base 10, some number lah. Give it up. Maybe you test 7 here. Let's see whether it's 7. Let's give it a try.
It's 7.
Yeah. Do you understand? This is the basics of logarithm.
Yeah.
Test this two option with logarithm base e, also known ln, logarithm natural. Please try, just to make sure everything is correct.
But what do I put?
You should put in a very similar way as this, logarithm canceling in this canceling logarithm. If you have to ask me how, you don't understand, and I want you to understand.
Okay, then
Try.
I don't
Please try.
understand.
Okay, try. Try following this. Don't just ask for it. Try following this by using logarithm base e. Yeah, I'm gonna share my screen. Just ignore my screen share. Please try.
Okay, here's my answer.
Right. So if this is text, we have a textbook right now. I'll ask you to immediately practice the most basic question. Then you will see that this is used very often. Okay.
Okay.
Fair warning, your teacher will teach this a bit differently. I strongly suggest if you understand the canceling concept, you will apply the canceling concept instead of the way your teacher do it. Again, a guarantee, if you do it this way instead of the teacher's way, which is more like magic, your teacher is more like magic, this one is more like understanding. If you do it this way, it will not be penalized. It will actually be looked upon favorably. Don't ask me why the textbook and the teacher do not teach this cancellation method. I do not understand why they don't do it at all. I really don't understand. They insist on doing the magical way, so to speak. Doesn't really help when things get hard. This understanding method, at least when things get hard, you can still make sense of things. That's why I teach it. Fair warning,
Okay.
yeah, Abigail? Right. Now, we don't have a textbook, so I have to teach you slightly further. This is not ideal at all. By that, you should be practicing a few things. Now, I will teach you one thing. The first law, how to overcome the limitation of your calculator. Your calculator only log base 10 and only log base e, correct? These are the calculator limitation. But in your question, you will have log base 2, log base 5, log base whatever. So here's an example. Let's say the question asks you, what is log base 2, 3? This will certainly be an ugly number. How do I know? How do I know that this is certainly an ugly number? Look at this forward. Log base 2, 8, not ugly. Log base 2, 3, definitely ugly. How do I know?
Well, you can't make 3 into like an in this.
2 base, precisely. In this base 2, you cannot. Ta-da! 2 cannot. But this one, 2 base. 8 is 2 base. Come on, you're in this. Yeah, this must be working here. Yeah, which is to say 3 lah. Right, so this is correct. So how to deal with this issue? Okay, this issue, we use the first law. The first law is called the base change law. It's called a law because they don't bother to explain why it works, but it always works. So that's the good news lah. It always works. The bad news is you don't understand, but you're going to use it so often. After a while, you don't think too much about it. You just use it. Okay. However, that said, it is not understood why it works. It just works. So I'm going to do a base change here. I'm going to base change to what your calculator can do, right? For example, log base 23 will be log base 10, base 10. I put the 3 here, I put the 2 here. This is, I just apply the law. It totally does not make sense at all. It does not make sense. How come this 1 logarithm become this 2 logarithm? It just does not make sense. Let me repeat, but it works. It works very well. And I can apply other bases also. Log base E also can. And if I want, I can make it log base 7 if I want to, also can. Abigail, I'm not teaching you the reason why it works. I'm teaching you the pattern, how it looks like. Do you understand how this law looks like?
Yes.
Now, your calculator cannot show you this one. Your calculator, however, can show you 2 things. I want you to try these 2 things. They look very different. Do you think they will be the same? Let's try.
The answers are the same.
This is the sole proof I can offer you using calculator lah, that base change works. That's the sole proof, because there is no reason why they should be the same. But turns out they are the same, surprisingly. If you think about it, it's very surprising. There is no particular reason why. Do you understand what I'm saying?
Yes.
Now, in exam, you won't be using just 10 and E lah. Remember, you have to use base 7, base 4, base 3. I don't know. Do what you like lah. Do what you like. But for calculator purposes, if they ask you what's log base 23, you press the calculator like that. Make sense or not?
Yes.
Whatever ugly number that is, that will be true. Now, I'm asking you to take that ugly number and then 2 power that ugly number. Put this ugly number here, please. And tell me what is the result. 2 power that ugly number.
3.
Does that make any sense?
Yes.
Because 3 turns out is 2 power this ugly something. The log base 2 cancel this 2. You get this ugly number. This is another proof I offer you. Base change works. If base change doesn't work, then this will be wrong. But turns out base change works. Not bad. I hope I'm trying my best to make sense.
Yeah, I understand.
Now, I'll show you the second law, because there are 3 laws, right? I'll show you the second law and we have no more time already. The second law also doesn't make a lot of sense. However, it works. That's why it's called a law. They don't bother to show you why it works. They just say it works, you're going to use it. Now, to deal with the 2 lah, So I focus on 2 times log base 38. I claim that this will become equal to log base 3, 8 power 2. Look, the 2 simply jumps in. The 2 can jump in. The 2 can jump out. They call this the power law. I mean, okay lah. Let's just admit to ourselves that it doesn't make sense. How come it can go in one? What's going on here? I mean, I can try to explain it lah. I can try, but I'll just stick to the fact that it doesn't look like it makes sense at all. You kind of just remember that it can go in and go out at your will.
Yes.
How do we test that this is correct? Again, this cannot press calculator, ma. So I offer you a proof. Instead, base 10 or base E? You choose?
10.
Okay, log base 10, log base 10. I do a base change lah. What do I put on top? Base change. Doesn't make sense. Just follow the pattern. What do I put here?
8 power 2.
No, 8 and 3 first. There's a 2 times here.
Oh,
And then
okay.
it should be equal to, again, log base 10, right? Log base 10. What do you put here? 8 power 2 lah. And this one is 3. Please see for yourself whether they are the same or not. If they are the same, the second law is working. Are they the same?
Wait, I'm doing it right now.
Yeah. Very important. Your calculator typing skill better, very good, and very fast in logarithm. I hope this shows why. I'm already tested. They're the same? All right.
Yeah.
This power law doesn't make sense, but it works very well, and it's not very confusing. I mean, again, to be fair, it doesn't make sense, but it's not that confusing visually. I offer you the second proof. The second proof is you're going to take that ugly number and simply put it here, correct? If you put 3 power ugly number, what will be the answer? What do you think? What will the answer be?
I get 64.
And does that make sense or not? Look, this is how it works. Log 3, 8 squared, correct?
Yes.
Remember the basic thing about logarithm in this, they cancel each other. Base 3 in this, base 3 log cancel each other. You end up with what?
64.
Which is 8 squared. Do you understand?
Yes.
This is another proof that the power law works. And we will be using them just daily one in every question in exam.
Okay.
This is the first time, I believe, you learned a topic earlier than class. This is probably one class session. We covered this in 35 minutes. Okay.
Okay.
I will see you next Thursday. And
Okay.
good job.